In this tutorial, we will use the Demo1 project, which is available by default upon creating an account. Click on Demo1 to open the model network. Clicking on My Projects at the top left corner of the interface will take you back to the list of projects available under your account. Clicking on How To takes you to a page with video tutorials on using this modeling platform. Clicking on Back To takes you back to the project page where we initially opened the network. The panel on the left side indicates the name of the network. It also contains several subpanels which can be expanded or collapsed. At the top of the panel, there is a green button used to run the model. The button in the middle provides access to advanced network utilities, for example, for importing or exporting network data. Clicking on the button to the right opens a panel on the right side of the interface which contains editable network details, settings, and information. The Tree button opens the network details and inputs. Let us change the name of the network. Expand the Details panel and change the network name from Demo1 to Training1. To save this change, click on Update Details. The simulation start time step, end time step, and the time step resolution are found in the Input subpanel. In this example, the end time step of the simulation is December 2047, and the time step resolution is monthly. Change the end time step to 2045. You will see that these changes are automatically saved. The spanner button expands the network settings subpanel. Here you can choose to display the model labels, link directions, and tooltips. You can also choose to automatically hide the panel on the right side when not in use. Finally, clicking on the information icon shows the network information, including the network ID and type. Let us now run the model. Press the Run button to open the Model Run window. The network ID is an automatically generated unique number and is also at the end of the URL of the network. By clicking on the scenario ID, a drop-down menu will appear. You can select the scenarios you wish to run. In this example, we will select the baseline scenario. By default, the output frequency is the same as the frequency of inputs. We will use this default setting in this tutorial. Two solvers are available for running a model, GLPK and LPsolve. These are free solvers and are able to handle large-scale linear and mixed integer programming problems. GLPK is the default selection and will be used in this tutorial. Additionally, you can tick the Check Model switch if you would like to perform a model check before running it. Click on the Submit button. In the left panel, you can track the status of the model run. Blue color indicates that the model run is in progress. Yellow color indicates that the model run is in queue, and green color shows that the model run is completed. If there is an error during the simulation, the color of the model run becomes red. Each run can be deleted by clicking on the rubbish bin icon. A model can be rerun by clicking on the circular arrow icon. In the left panel, model scenarios are available in a drop-down menu under the Scenarios section. Each scenario can be cloned, edited, or deleted. You can refresh the list of scenarios by pressing the rightmost icon. Click on the Build subpanel to show the types of network elements available for building models. There are two types of network elements, nodes and links. The search section can be used to search for an element in the network. This is particularly useful with large networks. Search for a node named myCatchment. There are tabs at the top center of the interface. So far, we have been in the map view. The Resources tab can be used to edit or remove nodes and links. It is also possible to group network elements located within a certain spatial domain or share common characteristics. The Data tab can be used to edit the attributes of the network elements. Alternatively, the attributes of an element can be modified by clicking directly on the element in the map view, as will be shown in next tutorials. The Metrics tab provides functionalities for spatial and temporal aggregation of model inputs and outputs. This will be discussed in more detail in a later tutorial. Finally, there is a tab to add custom operating rules. This tab will be discussed in more detail in a later tutorial.